Thank you very much. I'm really happy to be here. It's a really honor for me. I have been here for over 10 years ago, also to arrangement like that. And at that time I saw a very good architecture. It was really a happy architecture at that time. I can see it still is. So you still have the nerves in what you are doing here. What I should talk about is, you know, in my heart is gypsum. So I have to talk about gypsum. And maybe it's also in your heart. I can say, how many have had a beer yesterday? How many have had a beer yesterday? No? How many have had a soda yesterday? How many have eaten yogurt yesterday? Oh, not quite a bit. Because you know gypsum have an E516 and it's used when you are making beer and yogurt and things like that. But we can also make it for plasterboard. So that's what I will talk about. What you see here is for our reception in Danoline, and it's made with a GoPro camera, so it looked more dramatic than it is, but it's a start anyway. I will first take you through some of the products we are making. You can see here our products is mainly suspended ceilings, as you see in the top. You can also see the wonderful things here behind me. Also for school building, which are very common to use, perforated ceilings. And here also for conference room, it's for turning torso in Sweden. And you can also see it's also a possibility to paint them. We'll also come through what we else can do with plaster. Here you can see as wall covering and also covering when you are cladding out the gap between. Also in sports halls, because it's very impact resistant, the board. And here you can see in a corridor, on a hospital, and on a cinema where they are used as sound diffusers, also colored, and as wall covering, you can see here, and curved conference room in Saudi Arabia, and here as clouds also in Saudi Arabia. And here's the IT University in Denmark, and you can see all those parts up here, and here, and here. It's also plaster, and also the part here is also plaster. I say it's very easy when you're working with gypsum boards, because you can take a piece of paper, and then you can fold it, and then you can make it just like in plasterboard. You can perforate it just as when you're cutting holes. You can use colors as you will. So there are many possibilities. And that was also one of the possibilities. I was sitting together with an architect in Saudi Arabia and told him that it's really, really easy. And then it said, can you do the ceiling like that? I say, oh. Maybe it costs time and it costs money. So maybe we can do that. And that's also what the things is about. Sometimes it costs time and money. And I know for many architects, to go into a project, it can be difficult to say, okay, we want to have something sound absorption, or we want to have some shapes or whatever. Then they always talk about money. And I will tell you that using the product, it's a very good business in a way. It's not only to make structures, it's not only to make absorption, it's very good business in a way. Why I'm saying that? There have been made some investigations in Denmark by a professor. He said, first of all, we are spending 90% of our time indoor. It's for school, this one. And pupils, they're using 2% of their awaking time in a school class. And when you are in a Danish school, under the first 10 minutes, the CO2 level will come over the 1,000 ppm, which are very bad environment in a way. And when the CO2 level is too high, you have difficult to concentrate, very difficult to concentrate. And it also have an influence our well-being. So you can say, in Danish money, it costs the community, or you can earn of the community this kind of money. It's the same if you are doing the investigation by acoustics, totally the same. We also are changing quite a bit because we also have what we call experience economy. Experience economy becoming more and more a question in Denmark because, you know, in Denmark we have very good cooks which are making very good famous food, you know? But they are serving their famous food in a very noisy environment. And we have difficulties to concentrate of two things. So when we have much noise, then we are concentrating about the noise, then we can't taste the food. So this become also an issue now for this. So what we really need is like that. We really need the nature in good acoustics and things like that. But when we are talking about acoustics, we know when we are putting in our acoustical material, we are often putting it up here. Oh, wow. Yep. Now it's a good acoustic environment, maybe, but it's not. There are in acoustics 4 dimensions. We heard before about echoes, because the most things we heard in a room with just square is echoes. So the sound we heard most is the sound between this level, this wall, and those 2 walls. That's the 3 dimension, and then we have the scattering dimension, which are here. So when we are talking about the ceiling, the acoustical ceiling, it will only influence this. When we are talking about those one, they will influence this and this. So the result will be that. That means even though we are putting in the acoustical material, we are getting bad acoustics because we are recognizing the echoes between the walls. And what is an echo? When can we hear echo? An echo is when we can hear difference of 50 milliseconds. What is 50 milliseconds? It's 70 meters. So if you have, let's say, 8.5 meters from here to there and back again, then you can hear your own echo. So that's the most thing which have an influence in this room in here. A better situation is this one. When you're, for instance, putting in furniture, you know it. When you have put in furniture, then the absorption is very good, because then you're becoming some diffusion, not absorption, diffusion. Let's say that the sound is becoming another direction. When you have more directions, then you also become a more efficient ceiling. Let's say when he's talking here, wow, and the sound is spreading out here, the absorption surface is much bigger. The same if you have absorption material here on the wall, you're spreading out the sound, it's hitting the ceiling, spreading out the sound, and so on and so on. So the 4th dimension I was talking about is scattering, becoming more and more efficient in here when you have the scattering. And therefore, you also are getting much more sound absorption. You know it for when you have some structure into the walls or whatever you have, it gives scatterings, not absorption. Here you can see some figures we have measured. The first figure we have measured is an empty room with the sound absorbers into this. Then we have put in some diffusers on the wall, and you can see dramatical it fall in here. And here you are putting in furniture and so on. And then it's also fall dramatical. I saw that figure before, but use it again. So you have some element where you can use for this scattering effect. You have, for instance, if you are curving the wall in this direction, not in that direction, it's collecting sound. Or if you are angling the wall about 6 degrees, or if you have some perforation, it will also give you the scattering effect. Furniture will also be careful for tables, big tables, because they are reflecting sounds and things like that. So all start with the architecture, you can say. It's not only the acoustical material which is saving you, it's starting with the things you are doing in the first point you are making on the drawing. So already there, you know how the sound will move, which direction it will move. You already know it from there. If you have glass surface, you have to have something on the other side to spread the sound, and so on and so on. So it starts with architecture. You can say the acoustical material is only to get the tune. It's only tuning. It's not the absorption, or the acoustic itself. It's only tuning. Should I say, because I'm selling acoustical material, but anyway. So the ideal things, you can see, the things which are not ideal, here you are getting the reflection. Even though you have the diffusion here, you need something in the ceiling, but here you have the optimized ceiling, you can say, perforated tile, or should I say, at the wall and then at the ceiling, and that's the most optimized situation. Here we are. But sometimes you must also say, okay, what can we also give more than acoustics? Because when we are looking at acoustics, you know, we have to have a hollow space in a way. And then we were thinking about what can we do with this hollow space in here, because the hollow space, okay, you have lots of equipment here. And then we thought about if we could put in some ventilation kit, when we could use this as a ventilation grid or the ceiling, because we have the perforation. So we could put in pressure in here and then get the airstream to go down in that direction here. We have made some measurements, and it looks very, very nice because we are making measurements so you can see the smoke development and you can see the smoke coming down. And different from normal grill, here you have a very even airflow. It's not an airflow under the grill, but it's an even airflow, so you don't recognize this when you're sitting in the room. You know, if you have a grill over your head, you can recognize it for here. You can see I'm sitting under this one very long time, so I don't get so much here. And but there you don't feel the airflow. So you're getting a very, very good environment for that. On top of that, we are putting in what we call KNAUF technology. KNAUF technology is a zeolite which are putting into the gypsum core. And the zeolite is cleaning the air, is taking out formaldehyde from the air. So the flow we have here in between the perforation here, it will clean the air at the same time. So you are getting acoustics, you are getting ventilation, and you are becoming clean air at the same time. The zeolite is a drained crystal, as you can see here. I have made a picture for that. And when you drain the crystal, it becomes a very big surface and also negative loaded. So when the gases is passing, they got cleaned. Another thing about, you can say, the low pressure ventilation. You can see this is a traditional one here, and we have the crossing pipes normally. You know, you have the air inlet, and you should have the air inlet outlet. Here, you only need to have air inlet, and you don't have the crossing pipes as you normally would have. And you can say, what kind of money do this give to me? It gives, first of all, you have lower installation cost of doing this, because you only need the air inlet pipe as you have here. You don't need the two you have here. But it also have influence on the building height. You can see when you have the crossing pipe here, or you don't have it here. So when the guys in Dubai have used this system, they could have lowered the building 300 meters, and they could have saved 4 to 5% of the building cost to do that. I know in Dubai, you know, you're building so high as you can, but anyway, yeah. So now we have been in some whys. You could use gypsum. I need some last why, and this is about our outdoor things, because when we have built up our boards, it's very simple in a way. It's very simple. You can say you have plaster, you have some cardboard, you have some paint, and you have the acoustic felt, and you have some metal clip. Very simple product in a way. It's so simple that it can be generated. The first thing is, how do we become gypsum? Where's the gypsum coming from? This is the biggest chemical factory in the world we have here. Because when, for 1,000 years ago, the volcano break out, it made sulfide, SO3, it's called. The sulfide is very poison for the community, you know, because we are getting this from power stations today, and we are trying to clean it. But when the sulfides are falling into water, and they are coming very close to a reef, CO3. So, then they are picture plaster. So in normal seawater, there's 0.3% of plaster. So it's running here. Here's CaSO4, and it's binding 2 molecules of water, 2,2,0. Look like that. So you can say, how do we become that? Because it's difficult to take in seawater and then making plasterboard. But the nature is making plasterboard itself, because it only needs some sun. The sun we do have. So when you, for instance, have a lake like this here, there's a water into the lake, the sun is shining down here, and the water is leaving, you'll first see that there's laying chalk here. The next part here is gypsum, and over this there are salt. So the natural gypsum we are becoming by digging out those lakes. And you know, around the Mediterranean Sea, there are lots of plaster down there, because all the Atlantic Sea have been into the Mediterranean Sea and been dried out. So much of the Spain is plaster. Cyprus is plaster, and so on. So gypsum is a natural crystal, and when we are using this, we are heating up this crystal here, heating out the water, and then we can make figures. As you know, when you're going to the museum, you see all the beautiful figures made of gypsum. They're made like that. But we are also getting gypsum from the industrial production of power. You know, from the power station where you're putting in coal, we have the coal laying here, you're putting into the power station, and you're getting SO3 out here. And then we say, okay, what can we do? We can do exactly the same as happened in the nature. We are putting in some seawater, like here, H2O. We are putting some chalk, CaCO3 in here. And then we are getting plaster. There's a plaster man going here. And then we are getting heat. That's things here. And then we are getting grid power at the same time. That's also a part of it. It's called flue gas dissolving gyps. And the last part we are using is recycled. All the waste we're having on the building side, all the waste we are making our factory will come back to us again. That's also why we have built the board up so simple that we can break down the board again. So from the building side to a recycle factory, to our plasterboard factory, and all the waste we are reusing here again. And then you can say the clever question is, what about the cardboard? What about the cardboard? The cardboard is being used to composing foodstuff. So there's zero waste, you can say, when you are using plaster. So today, it's looked like that. When we are building up our plasterboard, we are getting 68% from flue gas. We are getting 20% because we can't get it anymore from collecting stations. And then 10% are natural because we need some more of this. And then the 2% we are reusing, and paper coming from waste paper, from newspaper, we are using as cardboard is going further to, you can say, composing. So one last thing is to say here, okay, what about plaster? What should we do about that? Because, as I said, plaster ceilings can only be old-fashioned in a way, because they will keep the same properties all the life it has. That means if you want to color, you can say the board here, you can use a roller, and it will still have the absorption qualities. Also, the fire qualities will be into this. So it can be crushed down, made to new boards, made to new design. Thank you very much.